Hi, everyone, and welcome to the Camunda BPM 7.9 release webinar. We're super pumped to have you here today, and we have a jam-packed webinar, so we'll get straight to the point. My name is Daya, and I'm your moderator for today. I just have to go through two housekeeping items, which are, first and foremost, this webinar is about asking questions, so please ask your questions. There should be a text box, and you can type in your questions there, and we'll answer them at the end of the webinar. And as well, we're going to be covering a lot of things like microservices, external task patterns, and history cleanup. So if you miss anything, this webinar will also be recorded, and we'll send you the recording early next week so you can watch it again. With that being said, I'm going to pass it on to Jacob to take us along.
Sure, yeah, thank you, Daya. Thank you so much. And welcome to everyone, yeah. So great to have you. Great to see your interest in Camunda BPM version 7.9. I'm here together with Daniel, our VP of Engineering, and we want to, of course, explain, but also demonstrate some of the new highlights that you will find with 7.9, which has been released yesterday and is now available for you to download and use. So before we look into what's up, really, I would like to have a little, spontaneous poll. So it would be super interesting to learn who of you is using Camunda BPM already, because that would allow me to adjust to that. And, there's an introduction explaining Camunda BPM, which we can, of course, skip if you're already using it, like all of you. So the poll is running right now. Very helpful. Thank you. So right now it looks as if the majority is in developing mode. So you're obviously already hands-on regarding Camunda BPM, which is great. Close to a third is in production already, and then we also have some who are just evaluating. We almost have nobody here who's not even evaluating Camunda BPM, which kind of makes sense since this is about this product, of course. Cool. But this means that some of you are still beginners, and therefore I would like to give a very brief introduction what Camunda BPM is about, what you can do with it. I'd like to do that by telling the Camunda story, which is brief and simple. So Bernd Rücker and myself, we started the company 10 years ago, actually as a lifestyle business, a bootstrap lifestyle business for consulting. We were very much into a thing called business process management and wanted to help organizations apply this discipline, whether it be process mapping or technical workflow execution. So I think we're having issues right now with the poll. Here we go. Sorry, I had to stop that first. Okay, got it. Thanks for the support, guys. All right, so we did this 10 years ago, was quite successful, really. So we wrote a book about BPMN, which became very successful. That helped us a lot. And after 5 years, we figured in 2013 that the world would actually need an alternative to the existing process automation products that were out there, predominantly by bigger vendors such as IBM or Oracle. So we wanted to provide something that we found more developer-friendly, lightweight, with an open architecture, and was kind of natural to do this in the fashion of an open source project that we launched back then. And when you look at the Google Trends graph here on the right-hand side, obviously this is when things became interesting for Camunda as a term, so to speak, which is obviously due to that open source project. So now, fast forward to today, 5 years later, there's like thousands of open source users, some of them very big organizations like Goldman Sachs using Camunda for the global workflow infrastructure. Also exciting use cases like NASA and JPL for space missions. And then we also have more than 200 customers of our commercial platform, which comes with additional features, support and maintenance, etc. From insurance industries, for example, media industries such as Universal Music, who deliver their content to marketplaces such as Spotify or iTunes using Camunda, or T-Mobile, who provision their SIM card contracts in Austria using Camunda. All right, so that's the story in a nutshell. So for those of you who are just getting started, it's important to understand that BPMN is really the centerpiece here. BPMN is a standard that allows you to describe workflows basically by defining tasks, things that are supposed to happen, events, things that we are reacting to or that we are waiting for, or also events that we are actually announcing. So it's relatively close to what you will see with an event bus, for example, which is often used for microservice architectures. So this is really like relatively closely aligned, and therefore the use cases are also not that far away. However, with BPMN, we can describe more sophisticated flow logic in an if-then fashion, like if certain events happen, the workflow starts. We're waiting for certain events. They determine what should happen next. We're making certain decisions to look at the data and then decide how we should proceed in the process. So it's obviously a quite sophisticated way of expressing flow logic. BPMN is a standard, as I said, an ISO standard, so it is really, it's here to stay. It's solving this problem of describing business processes in a way that is easy to understand for business users even, and at the same time directly executable. So we are actually looking at source code when we're looking at BPMN flowchart diagrams. So those two pillars made BPMN very successful almost 10 years ago already. So now it's a well-arrived standard, and therefore you can also count on it in the long term. So a BPMN workflow engine, like the one that you will find with Camunda, takes that serialized BPMN flowchart diagrams and interprets them. This is how we turn this into a running workflow. So you can see it here on the left-hand side. We have the flowchart, we have the corresponding XML, literal source code interpreted by the engine, and here we go. This is how it works, and it means obviously that developers do not just get like in many of advantages when it comes to implementing those workflows. They don't have to care about many things here because the workflow engine takes care of that. But it also provides direct real-time visibility into what's going on, also for business users. So, for example, this is a screenshot taken from a tool called Optimize, which is part of the Camunda Stack, which displays in a nice heat map which parts of the process are executed most often. And again, this is not a classical business intelligence data warehouse based thing. This is a real-time view on what's going on right now. We're looking at the source code and how it's executed. So I hope you get the difference here. The Camunda BPM stack consists of the engine, or actually the engines running under the hood. So we have the BPMN Workflow Engine. We have also a DMN decision automation engine. They're nicely integrated, but can also be used separately, working with relational databases, exposed via Java and REST APIs, and then we have certain applications that people can use for modeling processes, working in those processes. If we're looking at user task management, we have a very sophisticated product for operating processes in production called Cockpit. We are allowing administrators to take care of users and permissions, and the aforementioned Optimize, which actually pulls the relational database data into Elasticsearch as a big data repository, which then allows for sophisticated queries, reports, and dashboards. That is open source, not 100%, of course. So this means that Cockpit, for example, is mostly enterprise when it comes to the feature set. So when you have like mission critical, complex processes you want to operate in production, you want to rely on a sophisticated tooling for doing this. This is where Cockpit kicks in, and Optimize is also an enterprise product. All right, so typical situations that trigger Camunda BPM are, for example, if let's assume I have one of those heavyweight BPMS products from one of those bigger vendors I mentioned, and I want to get rid of that. I'm looking at a lightweight alternative like Camunda. That is very common. I might want to migrate from something homegrown, like I've coded my workflows in Java or whatever manually. I want to replace that with something more powerful, which might motivate me to migrate to Camunda. I might be a product vendor, such as, for example, Gainsight, customer success management product. I want to add workflow features to my product. Camunda is highly embeddable, so therefore it makes sense to look at that. I might, of course, automate my manual work for the first time, or as already mentioned, I want to introduce microservice-based architectures. This is a thing that is really coming up right now, so I'm going to refer to microservices quite often in this webinar, since the microservice paradigms are relatively closely aligned with how we're looking at workflow automation, and therefore we can certainly combine those two disciplines. All right, just wondering spontaneously, those of you who are now using Camunda or looking at Camunda, let's have a very quick next poll, and I'm happy to share the results with you again about your motivation. So I'm going to run this now, and it would be super interesting to hear if any of you can relate to any of these situations. So you should see this poll right now, and you should be able to let us know why you're looking at Camunda. And results are coming in. It's quite interesting, really. So I'm seeing, that's interesting. So it's around 20% replacing homegrown workflow tech right now. It's 20% replacing other BPMS products. But the majority is actually looking at Camunda for the microservice-based architectures, on par with adding workflow features to software products. Wow, interesting. Okay, so let's close this poll for now and move on in this webinar. All right. So there's some case studies and endorsements regarding this. I wouldn't go into too many details right now. You can look them up on the website. In a nutshell, Camunda BPM is very powerful when it comes to throughput and scalability, so you don't need to worry about that. And of course, this ability to bring together business users and software developers is a big reason for using Camunda. We're now running on Camunda BPM 7.9. We're quite proud that we are able to release Camunda BPM like exactly as scheduled for now 5 years running. So with BPM 7.9, we've invested 6 months of development. We involved more than 30 employees at Camunda for that, software engineers. We also are very grateful for all those external contributors who are helping us with their pull requests and features and community extensions. This is an open source project, and we're moving this forward together. So very excited about all the effort that has been put in, and of course also about the results that came out of this. So you see the topics here, the highlights. I would say we dive into this right away. And the first one is called Spring Boot support. And I would say, Daniel, could you walk us through this and explain what this is about?
Yeah, I'll try. We have, with the upcoming 7.9 release, we have upgraded the Spring Boot support. So before I get to that, for those who are maybe not so familiar with Spring Boot, it's gaining a lot of traction currently in the industry. More and more companies are either for greenfield projects starting right away for Spring Boot, particularly if they, for example, also go with microservice architectures but also for bigger applications. And then on the other hand, we have many people who have been using a more heavyweight container-based architecture and then migrating towards a Spring Boot-based architecture. So it's very attractive currently in the developer community. More and more people are using it. And we've picked up on that over the last years. It's actually also a nice community success story. So in the beginning, some guys from the community, Jan and Oliver, they were looking into this. They wanted to use it in their own projects, and then they created this community extension that gained quite some traction, of course, primarily due to the traction of Spring Boot itself, and then more and more people wanted to use it with Camunda. And then for not this release, but the last release, the 7.8 release, we said, okay, let's turn this into a fully supported part of the platform. So since 7.8, we have Spring Boot support, and then Spring Boot itself got a major upgrade this year, I think, if I remember correctly, in March, when they did a major release and released Spring Boot 2.0. And then we said, okay, let's make sure that we support the new major release of Spring Boot. So the Camunda BPM 7.9 release now comes with official support for Spring Boot 2.0, which is quite exciting. Then when we look at the Spring Boot ecosystem, of course, the way developers build applications there is that they assemble Spring Boot applications out of different building bricks. And we have 3 building bricks in Camunda BPM, which is the engine starter. And if you just want to use the Camunda engine, there is the REST API starter if you want to use the REST API on top of the Camunda engine. And then there's the web application if you want to basically run full-blown Camunda on top of Spring Boot. So it's kind of this use what you need approach that we're picking up on there, and that Spring Boot users can then also adopt with Camunda. So this is great. In the future, we will of course keep tracking the Spring Boot releases and adding more features on our side and supporting the upcoming Spring Boot releases as they come out.
All right, thank you. So next topic is a thing called external task pattern, and that's actually not a new thing. So it's been around for a while, but we have seen an incredibly rapidly growing adoption of this pattern. And this is why it makes sense to briefly explain it to those of you who are just looking at Camunda right now for the first time, and then explain how we're now supporting this to, like in a more extended fashion even. So first, it's important to understand certain patterns when it comes to integrating services, no matter if they're micro or if they're large services, no matter if they're via REST APIs or other ways of integrating it. So the traditional pattern is the request response pattern, which means that a workflow engine engine, for example, as the client here, might, run into a service task called charge credit card, and what it will do then is it will call a REST API service as an example here, and then wait synchronously for response and then proceed. So this is the request response pattern as we all know it, and some of us love it for good reasons. It's supported by Camunda BPM, always has been. You can do it directly from the engine. You can go via Java delegate. There's very different ways of doing this. No worries about that. It comes with certain advantages. I mean, it's quite intuitive. I want something to do something and I'm waiting for the response and then I proceed. So it's intuitive. It's very simple, widespread. And it also allows for synchronous service composition, which might come in handy if you have, for example, a front end that wants to display certain results right away, things like that. It's the, as I said, widespread additional pattern. Problem here is that the workflow engine would need to know the service endpoint. So this leads to a certain, degree of coupling. And also makes it more difficult to have like hybrid setups where, for example, let's say the workflow engine runs in the public cloud, but the services are, on-prem, maybe behind a firewall, which makes it more difficult to actively call them. So therefore, this would be a difficult setup, obviously. And this is a typical problem about coupling that, once again, we hear very often in the microservice ecosystem, which is an anti-pattern that is people trying to avoid. So therefore, they want to make those microservices more autonomous and allow for, autonomous development, deployment, scalability. So I'll come back to that later, of course. And what's also a problem here is that the services need to be available. So they need to be up and running. They need to have the capacity to actually process those requests. If not, the workflow engine will retry, which, might be an unintended behavior, which puts even more pressure on the service, for example. So that might be a problem. And also, especially in the media industry, for example, we heard of long-running services, for example, for encoding video files, things like that. So those, cannot be called completely synchronously. So we have an asynchronous situation here where the services might call back the workflow engine, which then requires a message correlation, which of course adds complexity. So what's the alternative? Well, it's basically about turning this upside down and saying, well, let's just assume, that a service task is handled a bit similar to how user tasks are handled in BPMN. So the workflow engine arrives at that service task and says, yep, now the credit card should be charged. So I'm just, stating that now. I'm not pending here and I'm waiting for a service to call me and pull that work and get it done and let me know it's done. So the credit card charge service here is completely autonomous, can be running anywhere, and as soon as it finds, it's time, it will poll for work, which might be, of course, happening continuously. So polling for work, and if there is work to do, it will complete the work, and then it will let the task know, or will complete the task by letting the engine know it's done, and the engine can proceed. So we can see here that, the engine doesn't know anything about the service. It's invisible, which once again is closely aligned with typical microservice paradigms. So therefore, we can see that, this strong decoupling in this regards allows for those services to be developed, deployed, and scaled completely independently. Can be happening in an event publish subscribe paradigm, can be using, an event bus such as Apache Kafka, things like that. So this is obviously, now very closely aligned with those ideas. And the task workers can run behind firewalls because, they're calling the engine, they're not being called. This wouldn't be a problem. They can pull the work based on their own availability and capacity. And again, if they're long running, that's much easier to implement. So there are clear advantages of this pattern, which is why, or we believe why it's being adopted so rapidly right now. It of course means as always there's a flip side. So in this case, it is not entirely possible to compose tasks completely synchronously. So if you want that, for example, to provide feedback on the front end, you'll probably be looking at a responsive or asynchronous behavior also on the front end side, which I believe makes sense anyway. The second problem is that you would need, of course, to implement that polling mechanism in your services. So far, people had to do that themselves. Good news is now with 7.9, there's an out-of-the-box solution. So we have out-of-the-box clients that you can embed in your services or use as a gateway, if you like, for Java and Node.js. And this is what I would love to live demo very quickly, in fact. So let me just do that. And I'm always excited when giving live demos because I always fear I might be messing up, but we'll see. So let's assume I'm now using my beloved Camunda Modeler, which allows me to create BPMN diagrams. I will really do this from scratch now, so I haven't prepared this. So let me just create this this process. What is again? Charge credit card. And I will define this as a service task. Okay. And the implementation here is external. And now I need to define the topic. So this is how, you know, those parties are connected at the end of the day by defining topics. So I just say, okay, this topic is called, I'm not even sure. I think it's called charge card, but I will double check because I'm following a tutorial here that you can also follow. You can find it in the docs. There's a new quick start guide which will walk you through this and will allow you to also implement those external tasks either using Java or JavaScript, namely Node.js, which I'll be using right now just for a change. So what we can see here is some source code that I can simply copy and paste. I've done that here already, so I did prepare a little. And what I'm doing here is I'm requiring this external task client that Camunda provides. You know, it's officially supported, maintained, comes with warranties, so you can really just use it. And I did that by, you know, running an npm install command, and now it's available for me. I have my Camunda engine REST API endpoint defined here, and now my external task worker subscribes for this topic called charge minus card. So I think this should be good. Charge minus card, exactly. I want to give that process a name. I'm going to call it technically webinar EN. Credit card EN is like the human readable name for that. And this should be it. So I'm going to save this. As you see, we had a webinar in German today already. So webinar EN. And now I'm using another awesome new feature in the modeler, which is the deployment feature. So I can now deploy this model right away. I don't have to, you know, bundle it as a WAR file or whatever. I had to configure the deployment endpoint, which is in default my local engine. And now I just deploy this. The deployment name is webinar EN. I don't need a tenant ID because I'm not using multi-tenancy here. And here we go. So now I can open Cockpit, you know, the tag operators tool, see if that worked. Here we go, credit card EN. So the process is there. Nice. Now I want to run this process. I'll be doing this by using a REST client. So I want to call the Camunda engine REST API to start workflow instance. So this is the endpoint. I need to provide the process ID. I think I called it webinar EN. I need to provide a payload in JSON. I'm going to provide two variables. So I want to purchase an awesome horse, which will be like, you know, $1,000. And this is what I want to do in this workflow. I admit it's a silly example. And this will now then run the workflow. So let me just send this. Looks okay. So let's see if we can see it in Cockpit. Yes, the workflow is now running, which means that it is pending now at a service task and waiting for a task worker to you know, pull the work and do it. So far, we don't have any task worker running. You know, I just showed you the source code, but I haven't yet started the task worker. So let's do this now. The task worker will simply, you know, ask for work under this topic. Will get the process variables, amount and item, and then simply, you know, spill this out on the console. So let's do it. I have to run this in my console with a node command. So I'm doing this now, and something happened. Let me just abort. So we can see, I pulled one task. I charged the credit card and $1,000 for the item awesome horse. Awesome horse. All right. So let's keep this client running. So you can see it's constantly now asking for work. So what happens if I start more workflow instances? Let's just do it. Okay. Another one. Okay, let's become more ambitious here. Clicking as fast as I can. So as you can see, it's sometimes pulling more than one task. You know, if I'm really quickly clicking here and there's more instances coming in, then there's more work to be completed, and the client is subscribed for that. So let's just look at the Cockpit again. So there's no pending workflow instance right now because they have been completed right away, obviously. History is telling me that I've clicked 69 times. Obviously, some workflow instances have been completed. I hope you're getting what this is about. It's an extremely powerful concept, really. So I think it makes sense, Daniel, that you might explain it a bit further also when people are concerned about load or whatever, So what can you say about that?
Yeah, actually I want to jump right in with the example that we saw that Jakob just showed us, where you saw that the client is continuously polling. And basically, I think in the example, Jakob, that you just showed, it was polling like once per second. Or maybe even more frequent than that. And the reason it was polling so often is, of course, that if a task gets created, we pick it up quite fast. Because the problem is the following, and I try to illustrate it a little bit here with this diagram that we have. So I have my service on the left-hand side, and then if it wants to do some work, it's going to send a pull request to the Camunda REST API. And let's assume in our situation, no task is available. Then the Camunda REST API is answering, no tasks are available. Now, the question is, how long do I wait before I pull again? Because if I wait a long time, then it could take me a long time to pick up a new task that is now being created. If I don't wait a long time, then I can pick up a new task that is now being created, but then of course I pull all the time, which could be a performance problem. Now there is, I try to illustrate that a little bit. So Jakob, if you go to the next slide, then here I made this chart, and what it is supposed to show is that there's this relationship between the backoff. This is what we call the time I'm spending after having pulled and received an empty response before I pull again, and then the maximum latency that I'm willing to accept between the moment in time when the task has been created and the moment in time when it gets executed. So what we see here on the x-axis, so the horizontal axis, we see a log scale of maximum latency that I'm willing to accept. So what we see here is, for example, if I'm okay with waiting 100 milliseconds for like after when a task becomes available before I process it, then of course I need to pull at least 10 times per second if I don't have any tasks. If I'm only willing to accept 10 millisecond delay, then already I need to pull 100 times per second. And if 1 millisecond is what I want to go for, then I need to pull 1,000 times per second. So that's what this chart is supposed to show. And what that would mean is, let's assume I have a microservice architecture with 100 nodes, and I want to have 10 millisecond delay. Then each node needs to pull 100 times per second. So I have 100 times 100 times pulling, and that is of course too much. The solution to this is then, for example, the long polling pattern. And this is what we have in the new Camunda BPM release, and it works the following way. So again, I have my microservice here. My service is going to pull, and then it sends a request to the Camunda REST API. And now no task is available. And now the REST API is not going to send back the response immediately. Instead, it's going to wait for a configurable amount of time. And if in the meantime a task becomes available, then it's going to return that task and send back the response. So now, if let's, for example, we assume that we have configured this, then here this chart shows that then we have a constant number of requests that we need per second to deal with these situations, and we don't need to compromise on latency. So for example, I can say I pull every 10 seconds, but with this long polling mechanism, and then if within 10 seconds there is a task being created, then it will be returned to me. Otherwise, I just pull again after this 10 seconds. And now, of course, I have an upper bound on how often a single microservice is going to pull the engine, which now allows these architectures to scale quite a bit more than what we saw before. Then how, as a user, can you now use this? It is actually quite simple because the fetch and log request was already there. The only thing that we have changed is there's a new property in the request body. So if you set this parameter async response timeout, in this example, I've set it to 1,000. So this would be 1,000 milliseconds. Then that means when I send a request to the engine is going to wait for a second, up to a second if no task is available, and only then it's gonna return the response. So if you have already the external task pattern in place, then you can just add this parameter, and then you need to do a lot less frequent polling.
Wow, super. Thank you, Daniel. So there's the thing that our consultants came up with, who said, hey, let's run a webinar on this, not necessarily external task pattern in general, but on this question on, I'm not a Java shop, can I still leverage Camunda? And they named this webinar, I think, tongue-in-cheek, as No Java, No Problem. I think that's a bit like sarcastic, but still, having the assumption your .NET shop, your JavaScript shop, or whatever, can use Camunda without touching Java? Yes, absolutely. That's possible now end to end. And there's a dedicated webinar on how to do this, which goes well beyond what I demonstrated today. So therefore, sign up for it. It's scheduled for July 12th. You can find it here on the website. But also, of course, if you follow us on Twitter, you will get the invite there, the registration link. So that could be very interesting. So let's look at some other highlights, and I'll cover this one briefly, I guess, for sake of saving time. So let's assume that you're using the Camunda Modeler, which is, as I said, the tool that you can download. It's free, and you can create BPMN diagrams and DMN decision tables using that. It's super easy to use, and of course, also you can then deploy those models to the engine, let them run. So one problem that we had with DMN was that DMN is very successful, which is a luxury problem for us, of course. However, it meant that we have, those super large insurance companies, for example, using DMN for complex decision making, and therefore the decision tables became also quite complex and also quite large. And at a certain point, we realized that the way this was implemented in the modeler, is not like performant enough. So it took too long to open certain large DMN files and things like that. It became inconvenient, and that's of course not acceptable. So what our engineers did is they literally rewrote this from scratch. It's a complete new implementation of DMN and the Camunda Modeler. Lots of efforts have been put into this, and I think it's really worth the effort. So I can very quickly just demonstrate that. I encourage you to try it out yourself. So this is the modeler. Of course, I can create a new DMN table here. There's lots of improvements in terms of convenience on how to use this, and so on and so forth. So that's already great. However, what I want to do is I want to open a large DMN file as we have seen it. Of course, this is now anonymized and like kind of an abstract version, but as we've seen it at those insurance companies. So this is a DMN decision table with 400 rows and 2 columns. I'm double clicking. I'm waiting for a second, and it's there, and I can just use it. I can scroll down to, let's say, the 400th row and just enter another one, and that's not an issue at all. So this is, I believe, a tremendous improvement when we look at those large-scale use cases that are becoming more and more relevant for Camunda BPM. All right, so let's move on. Cockpit, again, it's about UX, but I would say in the broader sense, it's also simply about features and capabilities. Cockpit is the tech operations product. It's at the very core, of course, of those mission critical business process automation projects. And there's a number of things that we did for the 7.9 release, but here's just some highlights. So let me look at a few of them. So for example, we're already tracking the user operations in the database, which means that, if people are using Cockpit and also task list doing certain things, sometimes we have to, have this available for audits. Can even be for compliance reasons. So this has already been logged in the database. Now in Cockpit, we can also inspect that. So this is just a screenshot. We can see here that, for certain process instance, certain point in time, a certain user did a certain action, and here's some more details about that. So this can of course be helpful to to figure out why certain things happened afterwards. And as I said, it's relevant for compliance too. Another thing that is relevant is, our customers are often global players, so therefore they need to localize the UI for their different branches. So this is already possible with task list. It's now also possible with Cockpit and admin. Let me just very quickly walk you through that, how that works. And you can actually look it up yourself on GitHub and the Camunda docs. So there's a GitHub repository which is actually open. So it's a community extension part where you can find property files, not just for Cockpit, but also for task list, for example, in different languages. You can create your own property files and donate them if you like. So here we have for Cockpit now a version in English and a version in German. It's simple JSON files. Just download them, put them in the Cockpit folder. You don't even have to restart the engine or don't even have to log into Cockpit again. So I can just quickly demonstrate that. My version of Cockpit is right now in English, obviously. What I can do now is I can simply change my preferences in my Chrome browser. So I can say German should be my preferred language and move this to the top. Now I just refresh really this page, and all of a sudden it's in German. So it's that easy, obviously, to make this available based on browser preferences, or also you can kind of override that and say, no, we're all, whatever, speaking French. So Cockpit is non-French in whatever country. Good. So that's not all. I'm not going to demo the core activities, I believe, for time reasons. But in a nutshell, what you can do now is, I can actually demo it because I've run this process already, so I can do it quickly. Let's assume I have a process in Cockpit, and it consists of call activities. So those are activities that call other processes. It allows you to basically decompose your process models in a vertical hierarchy for reusing sub-processes and things like that. It's a very common pattern. So what I can do now is I can look at those processes and those process instances. For example, here I can see, okay, there was one process instance and it went through this call activity. Now I can just click on this call activity in Cockpit and directly jump to the sub-process. So I can navigate down the hierarchy. I can also navigate up the hierarchy. Of course, there's no icon or no symbol here. So here on the left-hand side, I can see it. There's a super process instance ID. Clicking on that brings me back on top of the hierarchy. So that's, of course, very convenient for tech operations again. Good. There's another thing, which is called container-based authentication. And Daniel, maybe just in a few sentences, what is this and why should I care?
Yeah, it is about, for example, single sign-on. That's one of the use cases for it. So and everybody knows what it is. Person comes into work in the morning, signs on in their computer, and then they're just logged in all the applications that they're going to use. And for that, of course, you need to plug into the authentication mechanisms that we may have installed on a corporate wide or enterprise-wide scale. And what is now possible with the new Camunda version is that Camunda doesn't do authentication itself, but it uses the authentication mechanisms already provided by the container that it runs inside. So, for example, we can use the authentication mechanisms provided by Web3 application server or Spring Boot in our example, or WebLogic. And then inside the application server, I have a lot of possibilities to configure authentication against central authentication system, and then users don't need to log in all the time. That's just one of the use cases. There's other ones like advanced security and so on. But I think it's one of those features that is actually very, very handy when you roll out Camunda BPM in a large scale in a bigger enterprise.
All right, great. So let's look at another matter which is relatively complex, so I guess you have to explain it a bit, but it's also super important. And again, I think we've made big step here with 7.9, right?
Yes, and it's about the history of Camunda. So it's one of the very important pieces of Camunda. It's where a lot of the value is of a workflow engine. So most of you are probably familiar with this. So we have the Camunda engine, and it stores all its data in the database. And then inside the database, we have two buckets where data goes. One is the runtime tables. This is where we keep the persistent data structures that the engine actually needs to execute workflows. These are optimized for fast mutations. So if I need to go from one step in a workflow to the next, these data structures are optimized for that. There's a second bucket where data is being stored, and that is the history tables. And these are persistent data structures that record everything that has happened. So it has timestamps, it has which user did what, at what time, what is the, past value of a particular variable over time, all of this data. And now, of course, the history data can grow quite a bit, and then that can become a problem. Here, again, I've tried to make a chart. So what do we have here? Let's assume this example scenario. So I'm a company, I'm running Camunda, and I'm starting workflow instances at a rate of 1,000 per day. That's actually still quite modest. Many of our users do considerably more than that. So I'm starting workflow instances at a rate of 1,000 per day, and cycle time is on average 5 days. So workflow instance runs for 5 days on average. Let's assume in runtime data structures, one process instance takes 30 rows. And in the history, it takes 200 rows. It uses 200 rows in the database. Then if we look at this over time, so if we run this in production and let it run for 30 days, this is what the chart on the right-hand side shows. Then we see then, first of all, that the red line, which is the number of rows needed for runtime, grows for the first 5 days, and then it stabilizes, because as we start new workflow instances, we are also continuously ending workflow instances. So there's actually an upper bound of how much this can grow, which is good. What is interesting is the blue line. This shows the history. So, of course, here we only add and never remove something. So in my scenarios, after 30 days, I would have already around 6 million rows in the database. After 1 year, it would be more than 70 million. So that is interesting. Now, when we look at that, we've released a feature, I think with Camunda 7.6 or 7.7 quite some time ago, which is the history cleanup. And this is something that allows me to put an upper bound on history data as well. So here we've configured data retention, and we've said that the history data we actually only need it for 90 days. So once a workflow instance is ended, after 90 days, we can start deleting the history data. And then our chart shows that, of course, for the first more or less 90 days, the database is going to grow, but then it's going to stabilize at 20 million rows in the history. And this is actually what we want. Because now I can have a sustained operation of Camunda with sort of an in-flight data set. I may have spikes, I may have low points, but there's a fixed amount of data that I'm going to have in the database at any particular moment in time. Now, of course, this data that I'm now deleting from the Camunda database may be of some use to us, and Jakob can explain us on the next slide how you can deal with that.
Yes, exactly. So, I mean, you can say ironically, okay, I mean, I'm using the history because I want to create data. So now you're telling me I should delete those data. So what's going on? And obviously, in some cases, we want to, in fact, keep the data for more than, let's say, 90 days, for example, for business reports. And this is where Optimize kicks in. So as I said, Optimize is the business-oriented BI tool that is focused on workflow automation with Camunda BPM. So I have certain out-of-the-box reports here, like those nice and fancy heat maps and many other things. So I can create my own dashboards, share that with my business stakeholders, etc. And technically what Optimize does is it constantly pulls new data from the relational database using the Camunda REST API. So this means that, if I have a time window of, let's say, 90 days, and what Optimize will do during those 90 days will constantly pull, if you will, within seconds, all the new data that is being generated and store that for good in the Elasticsearch big data repository. So this means that if those data gets deleted after 90 days, that's not a problem because I can still access it and use it in my Optimize tool. So this specific mechanism is now becoming available with Optimize version 2.1, which is released in 4 weeks or end of June. So therefore, feel free to contact us if you would like to give that a shot. And there's already alpha releases, and we're happy to work with you to get this up and running in your case.
All right. So the history cleanup in Camunda was already there before 7.9. What is new now with 7.9 is the performance. Because it can be a challenge to delete data at the rate that we need to delete it at. And for example, in my scenario here, we said that every day we need to delete 200,000 rows. And if my calculations are correct, that is about 3 rows per second. That doesn't sound that much, but we already said that real life scenarios can be considerably more than 1,000 workflow instances per day. So what is now possible with 7.9? There's greatly improved delete throughput by the possibility to parallelize. So you can now run the history compaction or the history cleanup in up to 8 threads in the Camunda engine. And here is an example where we only used 3 threads. So we have 205 process definitions, a lot of historic workflow instances. We have the Oracle database, a single Camunda node, and then with Camunda 7.8, it was possible to delete about 19 workflow instances from history per minute, sorry. And now with the 7.9, it's already above 77. This is using 3 threads. You can go up to 8, so you can be even a lot faster. And then when we look at that over time, then we see that, for example, now within 1 hour, I can delete almost 100,000 workflow instances, while with the old release, it was only 25,000. And that is very, very critically important for our users because they need to have a sustained operation of Camunda in production. And that means that they cannot just have the database grow and grow and grow and never delete anything. And yeah, it's quite exciting that we now have these improvements. What is also there with 7.9 is more powerful possibilities to configure when actually data is being deleted, because of course the delete workload is going to add some stress on the database. So for example, people say that they only want to run this overnight, but not during business hours. That was already possible. And now this got even more powerful, because now you could say, okay, during, working days, I want to run it overnight, but then during the weekend, I actually want to have it run all day. And this is then kind of inverse to, okay, the actual work is being done during business hours, and then overnight we can delete stuff. So this is powerful tuning that is now possible to control when the history cleanup is running.
Oh, thanks, Daniel. So we're close to wrapping it up, and I have some news. I mean, this is really like a let's say something that I'm personally passionate about. You know that I love BPMN. I wrote a book about that together with Bernd. So I'm very happy to announce that Camunda BPM now, in fact, supports 100% of the BPMN symbols. Well, at least that makes sense to support for a workflow engine. So there was one symbol left, the conditional start event, which was not yet supported in the execution engine with 7.8. And big news, now it is actually supported. So this is great, not just because mission complete, but also because it actually makes sense. So how does this work? Just imagine you have 2 different decoupled processes. So both deployed on Camunda BPM, but totally independently. So they're both reacting to conditions that became true. So let's just assume, in the morning we have this today's weather forecast, and it's saying, hey, temperature today is going to be lower than 5% degrees Celsius. So in that case, this little process here is supposed to turn on the heating, maybe via, some Internet of Things API or whatever. So fine. We have another process which says, hey, if the temperature is higher than 25% degree today, then I want to turn on the aircon. So those 2 processes are simply reacting to facts that became true, in this case, the temperature. So this means that technically I can say, okay, so I define an expression for this conditional start event in the modeler, simply saying that I'm interested in a variable called temperature, and if this temperature variable is above 25, let's assume it's whatever, an integer, then this workflow will actually start. So what I can do now is I can leverage the APIs, either the Java API or the REST API, and can simply call that API and say, hey, API, just letting you know, the temperature today is going to be 28. So deal with it, if there's any processes that are interested in this fact, run them. If not, then simply forget about that. So my example now, Camunda would go about and say, okay, 28 degrees Celsius today. So is there any process that is interested in this fact? Oh yes, in fact, there is one. This one here. So now I'm going to run this process. So I think you're getting the idea, and it's pretty powerful. It's again, of course, also inspired by the event subscription patterns that we can find in the microservices world. So therefore, you can see how this is now converging. Another important thing, speaking of events and pub/sub patterns and microservices, is the signal event. So the signal event in BPMN means that we have two distinct processes that don't know each other. So if they did, they might directly call each other or send messages, but they're not. So what I'm doing here is that I say, under certain circumstances, I simply publish an event which says certain policy conditions have changed. And as it happens, there's some other process that has subscribed to that event saying, well, if I'm currently pending in this user task, which is about reviewing a contract, but all of a sudden this event happened, then I need to abort it and recalculate the contract and then let it be reviewed. So this was possible already with Camunda BPM 7.8. What now is also possible is actually transferring payload with those signal events. So I can say in a signal event, all right, I also want to not just let you know that this event happened, but also, simply transfer variables, process variables, that will then become available in the other process that has subscribed for that event. All right, we are basically there. As always, we're now supporting more technical environments, like the newest versions, Wildfly, JBoss, MariaDB things. And we also now have a Docker image, not just for the open source platform, but also a officially supported Docker image for the enterprise platform, which is, of course, great if you're an enterprise customer. And there's also a thing called Wildfly Swarm. Daniel, what is Wildfly Swarm and what can I do with it using Camunda?
It is, we talked about Spring Boot in the beginning. It's similar to that. It is also about having a lightweight deployment model where I can basically bundle the infrastructure that my application needs with the infrastructure rather than deploying the application inside the infrastructure, what we had in the past. And then, of course, with the emerging ways of building applications and deploying them and operating them, the whole, we said it a couple of times, microservice stuff that is going on. We have seen also some traction in this area, and now we have a community extension that we actually built ourselves together with some customers who wanted to start using this. We built it as a community extension because we're not at the point where we say this is fully, this is something we fully understand, this is something we fully support, but we are looking for feedback here, and you can check it out on GitHub and then start using it and give us feedback on that.
All right, great. So here's the final heads up before we come to the Q&A session. There's a conference coming up in Berlin, CamundaCon, where we basically gather the global Camunda community so that they can exchange their experiences and best practices and get to know each other. So this is awesome. And another great thing about CamundaCon is that our own core engineers are attending as well. So not just Daniel giving one of the keynotes, but also all those core engineers that are actually building this will be there on site, and they're eager to get in touch with you and discuss your use cases and how you might tackle them using Camunda. Also hear your feedback and your ideas and thoughts. So therefore, I would strongly recommend that you that you consider coming to Berlin end of September. Here's the URL. If you're using Camunda and you would like to hand in a presentation submission, the call for papers is still open for the next 3 weeks. So please hand that in. We have already received very, very amazing submissions from organizations such as Goldman Sachs and Vodafone and Universal Music, but there's of course more that we would love to learn about, and therefore please do that. And also just keep in mind the early bird tickets are available until end of this month, so don't be late to that party if you'd like to come. All right. This is it in terms of what we had to share. So I would suggest we're now looking at your questions. And just by the way, because I just figured I can actually share the poll results. So just assuming you're interested, I will try to do this now. Can you see that? Yeah. Okay, so 75% of you participated here, and yeah, it's interesting. So more than half are looking at Camunda because they'd like to add workflow features to their product. Quickly followed by this microservice-based architecture people. So this is obviously a thing that is coming up now, and I think we are pretty well prepared to help those projects with workflow automation. Okay, but now let's really look at the questions. So what do we have here? Oh, that's a lot. Okay. I'll start from the top. First things first. So okay. Okay, that's a question that is always hard to answer. It's about how we compare with other products such as JBoss, JBPM, for example. I typically like to stay away from those kind of comparisons, simply because we're obviously biased and we're obviously convinced that our approaches make more sense, such as the external task pattern, for example. So therefore, I believe it doesn't make sense to say, they have this and we have that, and so on and so forth. Also, it's not fair because we don't really know the product that well. I can say that we are, I think you have learned today how we see workflow automation and how we believe that it should be supported. And to my knowledge, relatively unique in this regards. So if this resonates with you, Camunda is probably the right choice. But that's all I would like to say regarding this question, at least in a public conversation. So feel free to contact us directly if you like. Someone is asking. Okay, so there's some questions that are probably better for the forum. Interesting. Does Camunda support executing DMN XML for decisions? Question mark. Run as microservice? Question mark. I will answer that myself, and then you can chime in, Daniel, if you say this is like if there's anything else to add. So yes, absolutely. So I mentioned that there's two engines. One is the DMN decision engine, and it's executing the DMN XML that you will get out of Camunda Modeler or other DMN compliant products. And yes, it is a very lightweight engine. Daniel, just wondering, how many megabytes does the DMN engine have? Do you know that?
Oh, I don't know, but it's less than 1.
Okay.
But I don't know if that is the way you define lightweight. But yeah, it's stateless. It's easy. It's super simple to use. It's in Java. We also have one in Scala, so it's and it's super fast as well.
All right, so I'm just asking because this gentleman referred to, again, microservice paradigm. So, of course, wrapping the DMN decision engine in a microservice and deploying it, making it available in different ways, that's absolutely possible and even quite common, really. Someone else asking, how about different microservice instances long polling for the same task? Wouldn't it conflict each other? That's an interesting one.
That is good. So the external task pattern it's actually a competing consumer pattern. So we have multiple competing consumers, the different microservices who poll continuously for tasks. It's our fetch and lock request. And then the problem the engine needs to solve is the mutual exclusion. So one task can only go to one microservice at a time. And what is interesting actually about the long polling pattern, we didn't cover that now, but what is interesting about it, so it actually allows us to get a lot of requests, and then we can put them in a list, and then we can actually batch the fetching and locking. So then a couple of microservices are polling us, and then we can, do the statistics on the different tasks that they want to receive, and then we can actually go to database once and fetch, and then return that, and then apply some batching effects here. So that what is nice about the long polling is that it actually makes the implementation of the mutual exclusion more efficient. I should probably talk more about that, but I don't think we have the time.
Yeah, but I think it's a great idea for a dedicated webinar, maybe even,
Yeah,
so,
we could do that. Yeah, like with what would be cool is to have like a real scenario where we have a couple of microservices that pull, and then some maybe on AWS, Kubernetes, and then scale it up and down elastically. Maybe we can talk to some of the guys and do a nice webinar on that. That would be cool.
Yeah, right. And also, just a tip. So there's a Camunda Day coming up in, I think it's one is happening in Copenhagen in 2 weeks. So it's a user meeting, and they're pretty big financial services tech provider called BEC. Will also talk about how they integrated their legacy applications using an event-driven architecture. So check that out. And also, we are going to be in New York City, end of June, where Goldman Sachs will be speaking. I'm pretty sure they will also be talking about, for example, those distributed systems and how they are integrated. And also in Amsterdam, for example, July 3rd, there will be, I think it's a tech startup, in fact, talking about their microservice-based approach using Apache Kafka in conjunction with Camunda BPM. So if you're interested in those kind of things, this is really like in the next few weeks happening. Make sure you visit camunda.com and click your way through to the Learn and then Events section. There's Camunda Days, and they are listed there. Or follow us on Twitter to get a heads up about that. I think we have to stop talking about microservices. I mean, questions are coming in mentioning this, but there's of course also other people who are interested in other matters. So let me just deliberately pick another non-microservice topic here. So, for example, someone's asking, looking at the demos, it looks like a strategy is towards headless BPM. Does that not make it expensive for customers to have independent UIs, which looks good and good enough to be taken to end users? So just recapping here, the question is, okay, if I have to like code my UI, well, this is nice because I'm flexible, but I have to code it, which is additional effort. Just letting you know, we have this tool called Task List, which is very powerful and very user-friendly. And we have a lot of customers who use that for involving their end users. Task List is based on AngularJS, so it's obviously an HTML5 web application. It's extendable with plugins if you like. It's localizable with your own local language. So you could say that Camunda BPM, it's true, believes in headless BPM as a concept when it comes at least to end user involvement. But then again, it also comes with kickstart tools and components that you can leverage. So you don't necessarily have that additional effort. Just making sure that this is clear. I'm not looking for, again, for questions that are not about microservices. Yeah, that's interesting. So, any plans for event-based external tasks to support serverless functions that can be triggered by HTTP requests or service bus events like Azure Functions? There's always lots of plans, but what's your thoughts, Daniel?
We actually have people doing that, and I think also Bernd wrote a blog post about that, if I remember correctly. Bernd is, beside Jakob, the other co-founder of Camunda, and he has a very popular blog, and he's writing a lot, and he has very good material on these topics. So we actually see that. We have one customer, and they that I now know about, I'm thinking about in this context, and it's a complete .NET shop, so they're running everything in Azure, the Microsoft Cloud, and the actual implementations of the service tasks are all Azure functions and then they have integrated this with the Camunda Workflow Engine using the external task pattern. So you can think of that like, a generic external task worker that is gonna fetch the tasks and then push them out to the Azure functions, and then the Azure functions can actually do the work and signal back for completion. And you can scale that quite a bit because while the Azure function is working, the Camunda engine doesn't need to have any resources open on our side, so to say. We have no thread blocked that waits for a response. We don't even, if we would do asynchronously calling things, then we wouldn't even have, that in some queue or some list or something. So that's quite efficient, and we see people picking that up more and more. So in terms of do you have plans? Well, it's there, but it's an example of where I would have a particular infrastructure and then integrate that infrastructure with Camunda, and all the integration points are there and people are already doing it.
Great, thank you. Someone is asking a question on how to use Camunda for orchestrating external tasks and having issues deploying it in the public cloud. I'm actually seeing a whole stack trace here. My suggestion here is that you put that as a question in the forum, because this is the best place for that. People will have maybe questions. Our core engineers are looking at that continuously. Will get qualified answer there right away. So just as an advice. Not much time left. So let's just look at two more questions right now. So there was a pretty good one, and sorry, I really have to apologize because I'm going to say the word again, but the question is really good. If a task is received by a microservice and then the microservice crashes, will the task be delivered to another instance of microservice? How will it know that the previous instance crashed and the task needs to be redelivered?
Yes, a very good question. So the way it works is when we fetch and lock a task, it gets locked for a particular period of time. So I do the request, and then we said it's mutual exclusion. So then I have the task for, let's say, 10 minutes. And this I can control when I do the fetch and lock request. So I have it for 10 minutes. And that means for 10 minutes, I'm going to be the only service working on it. After this lock expires, after 10 minutes, then the task is going to be given to another microservice potentially. So that means that this automatically heals. So if I die, another microservice is going to pick it up and execute it. What I can also do is after 8 minutes, I notice, I need more time. Then I can send another request, which is going to extend the lock. That is something that we built, I think, in the 7.8 release. And it came from situations where, for example, companies are doing video transcoding or things like that take a long time. And then, if you die, let's assume the whole thing takes an hour. Then you don't want to lock the task for an hour, because if you crash, then it will be locked for an hour. So what you do is you lock it for 5 minutes, and then after, maybe 3.5 minutes, you lock it for another 5 minutes. So you continuously keep extending the lock so that you get more time and nobody else works on the task. At the same time, if you fail to extend the lock via crashing, then somebody else can pick up the task and actually work on it. So this way you have the two things, making sure nobody else works on the task, but also have, again, an upper bound on the latency of when somebody else is going to pick up the task if you crash.
Cool, thank you. There's many more questions, but we can't cover all of them right now. So I would encourage you to do two things, and I will quickly show you where to do it. So first one is go to the website and just check out, as I said, the forum. If you have technical questions on how to use certain things in Camunda, no problem about that. If you're seriously evaluating it for like a project, where you really want to talk to us, which I would strongly encourage. If it's like something bigger coming up that you want to build with Camunda, just contact us. So just follow the simple form, get in touch with us. We're super happy to guide your evaluation and help you explain, of course, also commercial aspects of the enterprise platform. So whatever you have in mind, we're happy to help. And our sales reps, they sit directly next to our consultants and engineers. So therefore, you will get a qualified answer right away. And as I mentioned, last but not least, check out Learn and then events, and you will see there's the Camunda Con that I mentioned coming up. There's the Camunda Days. So for example, in June now in Copenhagen, Oslo, in New York City, end of June, Amsterdam, July 3rd. So those are the next opportunities to meet us in person in a city that is hopefully close to your place. It's free to attend, so I can really just recommend to take this opportunity. And of course, also we have a meetup ecosystem. So there's always meetups running. Organized by our community. Those are mostly evening sessions. So I think the next one is scheduled in Vienna. So check that out if you like. And yeah, that's basically what I wanted to share in terms of tips. And I think we're good for now, aren't we?
Yeah.
Cool. So thank you so much for attending. Thanks for your interest in using Camunda. Would love to help you being successful with it. So reach out if you like. Thanks for you, Daniel, and of course also thanks to you, Daya, for housing us.
Thanks, everyone. Have a great day.